Hey everybody, this is Dean and welcome to Photo Blue. Today I'm going to show you how telephoto compression works and what it is. I'm going to show you a couple of diagrams first to show you stuff about optics and perspective, and then I'm going to show you some actual examples to show you what it looks like in the real world. So I have a diagram here and I have what the photograph would look like up at the top here, and down along the bottom I have a diagram that shows how far things are from each other. In this case, we have two subjects which are close to each other and a camera that's normal distance using a standard telephoto lens to get this image right here. So in the next image, we're actually going to do an optical illusion that you've probably seen before, or you may have done before, where it looks like someone's standing in someone else's hand, or there's a building that's huge, like the Eiffel Tower or the Leaning Tower of Pisa, and it looks like the person has it in their hand and is holding it up. And the way you do this optical illusion is you move one of the subjects farther back so that it looks smaller because it's in the distance, and you just line the person's hand up with it. So you see along the bottom here in the diagram we have the camera, which is about the same distance as it was in the previous picture, and the person's the same size, but we move the horse back so the horse looks much smaller, and we've lined it up so it looks like the person's holding the horse in their hand. So that's one thing that happens because of perspective. The next example is probably one that you've seen in magazine ads and advertisements, where we actually will change the size of the sun, or how big the sun looks. So here's a normal picture, and the person's normal distance from the camera again. It's a standard lens. The sun looks normal size in the sky. The person looks normal size. And the sun is way in the background. In fact, the sun's millions of miles away. It's over 90 million miles away. So it always looks the same relative size in the sun because it's so far away that any distance you would be, or any place you move on the earth, it looks the same size. It doesn't change the size that it looks. So we go to the next image, and what's happened here is the person's in the same spot, but we move the camera way far back because we're using a telephoto lens. So we have to move as far back or far enough back so that the person looks like they're normal size, or like they were the size in the previous picture with the standard lens. And say we're magnifying this with 5 times perhaps, or not 5 times, say 10 times even. So the person looks a normal size. Well, the sun, which normally would look the same size no matter where you took the picture, has expanded like 10 times because we're magnifying it, right? But the person looks the same size because we can get far enough from the person to change how large they look. But the magnification is actually working more on the sun because it's like the relative size has gotten much bigger. So we get the illusion that the sun is really big in the background in a sunset. So you've seen that type of picture before as well, probably many times. So now we're going to go and look at some actual photographs. Now, this is 24 millimeter lens to the left and a 105 to the right. Now you can see sky in the background to the left, and you can see that there's no sky because the background's compressed. It looks like it's closer up. So it's actually a nicer looking background in this. It's less distracting. Now the angle may be slightly different. I tried to get as close to the angle as I could, or as close to the angle as I can, but when you're moving back, you run into things, so you may not be able to stand exactly the same spot. But if you look at this bush over her right shoulder here, it's much smaller in this picture than here, yet the relative size of the statue is about the same. And so it's the lens that's changing what it's looking like. So that's an example of telephoto lens compression. And let's take a look at another shot here. You can see that with the 24 millimeter, we see a lot of sky in the background again. And here's another bush right here, this different angle. And when we stand back and use the 105, the background compresses, and actually it looks bigger in the back. The background compresses and looks bigger or closer to the subject, and this is the same bush as this bush right here. So the bush it looks like it's much bigger or much closer. So that's the telephoto compression effect and what it looks like and hopefully you can use it in your own work when you want to make the background less distracting. That's one way to do it, because it may blow up the background and it tends to, the focus on a telephoto lens as well will get a little softer for things in a background, because the depth of field is much smaller. The other effect is with a 24 millimeter lens or a wide angle or an ultra wide angle lens, things that are closer to the lens exaggerate in size. So if you've ever seen a fisheye lens or an ultra wide angle lens picture where the person looks really close up in the front, or whatever is being taken looks really close up in the front, but the background looks much farther away, that's also kind of like the reverse effect of telephoto compression when you're using a wide angle lens or an ultra wide angle lens. I'm Dean, and this has been Photo Blue, and I will see you next time. Don't forget to subscribe, share, and like.